The dive deep answer that sounds great, but fails the bar raiser. The reason most candidates lose this question is that they describe exactly once semantics like a textbook, instead of like someone who has actually had to defend that guarantee when the pipeline is on fire at 3 in the morning. The question is, how would you design a data pipeline that needs to guarantee exactly once delivery at Amazon scale? The LP being tested is dive deep, which at Amazon means you do not stop at the architecture diagram. You understand every failure mode, every cost trade-off, and every operational burden that guarantee creates for your team. What the bar raiser is actually listening for is whether you understand that exactly once is a contract with downstream consumers, not a configuration flag you set and forget. Here is how most candidates answer this question about exactly once pipeline design, and it sounds solid right up until the bar raiser starts probing.
To guarantee exactly once delivery, I would use idempotent writes and track message offsets carefully. With Kafka, you can enable exactly once semantics using transactional producers and idempotent consumers. On the sync side, you assign each message a unique key and use a deduplication window to catch any replays. I would also implement checkpointing in the stream processor so we can replay from a known state after failure. For monitoring, I would set up lag metrics on the consumer group and alert on processing delays.
Describes configuration options. No evidence of having built this in production. Deduplication window sizing not addressed. The hardest operational decision. No acknowledgement of cost or latency trade-off exactly once imposes at scale. Monitoring scope to lag only and no mention of idempotency, key collision, or downstream impact. Here is what I am writing in the debrief right now. Item 1. Recites Kafka Transactional API. No evidence of production ownership or failure experience. Item 2. Deduplication window sizing omitted. This is where exactly once breaks in practice. Item 3. No cost or latency trade-off articulated. Exactly once is not free at Amazon scale. Item 4. Monitoring answer is shallow. Lag metrics alone do not protect the downstream contract. Verdict. Does not demonstrate dive deep. Same question. Same system design. Listen to how this candidate frames the guarantee from the first sentence.
I have built this guarantee in production, and the first thing I learned is that exactly once is a contract with downstream consumers, not a property of the pipeline alone. The design starts with idempotency keys scoped to the consumer's use case, not a generic message ID. For Kafka, I use transactional producers with offset commits inside the same transaction, and I size the deduplication window based on the maximum observed retry interval under our worst incident, not a default TTL. The real cost is write amplification and increased P99 latency. On our highest throughput pipeline, we saw a 40% latency increase. So we negotiated exactly once only on the paths where downstream duplication caused financial impact. I also instrumented idempotency key collision rates as a first-class metric because silent key collisions are how this guarantee fails without alerting.
Frames exactly once as a downstream consumer contract. Correct mental model. Idempotency, key design, scope to consumer use case, not generic, shows depth. Deduplication, window size from real incident data. Production ownership evident. Latency cost quantified and trade-off negotiated with stakeholders. Dive deep and ownership. Notice what changed. Every design decision is anchored to a production constraint, not a documentation page. Item 1. Frames exactly once as a downstream contract. Demonstrates correct system-level mental model. Item 2. Idempotency, key design driven by consumer use case, not default configuration. Item 3. Deduplication window sized from observed incident data, clear production ownership. Item 4. Latency cost quantified, trade-off scope to financially impactful paths, dive deep and frugality. Verdict, strong signal. raises the bar. Before your loop, run your answer through these 3 questions. Question 1. Can you name the specific failure mode that broke your exactly once guarantee? If you cannot, the bar raiser will assume you have never actually operated the system. Question 2. Have you quantified the latency or cost trade-off of maintaining this guarantee at scale? Without a number, your design answer sounds like architecture theory, not production engineering. Question 3. Do you monitor idempotency key collisions as a first-class production metric? If not, you cannot actually prove the guarantee is holding for downstream consumers. If you answer no to all 3, you have not demonstrated dive deep. You have demonstrated you read the Kafka documentation. How do your real stories score? Get a personalized report scored against the interview rubric Amazon uses for your role. Find it at interview101.com.